one thing that I saw this morning during Jeff's presentation, it showed embedded vision at the edge that over 80% of solutions were all detection or classification. Segmentation was down about 40%. So if there's one thing you get out of it today, hopefully it's, segmentation is ready for edge processing today. It works, it's approachable, and it's not quite as intensive as maybe it first seems. So we'll give a quick introduction to what segmentation is, go over a couple practical examples, discuss the various types of segmentation, and then see how accuracy is measured. And importantly, what are computational requirements? Can we do this on edge processors? And finally, there'll be a few resources to learn more. It is a short talk, so if you're really interested in this, there's quite a bit of reading you'll be able to do. So to start, what is segmentation? I think this image does a good job of showing, it is fairly straightforward. It's just separating pixels from the image into what they are. And the level of granularity is really defined by your data set and the model's capabilities. So here on the right side, we see balconies in purple and windows in red and the building in yellow, storefronts in green. The colors are, totally arbitrary. And, in a normal application, you're not actually going to be generating the colors. You'll be acting on these segmentation outputs. But when visualizing how the model looks, this is the type of example that you're going to see.